today we're going to find, or more specifically, classify different polygons on the coordinate grid. In other words, what we're going to do is we're going to have a grid and you're going to be given coordinates. You're going to have to draw the picture and then answer whatever question it is that they're asking you. Or you might be given a picture already and then asked to do things to figure out what you need to figure out. Now, on the screen in front of you are three formulas that you're going to need depending on what you're being asked to do. Now, you'll be given each of those formulas on your reference sheet. So you don't need to copy down the formulas themselves. When you take your test or when you take the EOC, you'll have a reference sheet with the distance formula, the midpoint formula, and the slope formula. What I want you to do is copy down when to use it. Notice how for the distance formula, for example, we would use the distance formula to help determine whether sides are congruent or whether diagonals are congruent. What I'd like you to do is copy that down, pause the video, copy that down, and then we'll move on and I'll show you how it works. Okay, so here we have a grid. Let me get rid of what's here. So what we want to know is a particular triangle scalene, isosceles, or equilateral? Now, of course, you have to understand what scalene, isosceles, and equilateral mean. Otherwise, you're not going to be able to answer the question. Scalene, S-C-A-L-E-N-E, scalene means no sides congruent. Isosceles means two sides congruent, and then finally is equilateral, is all sides congruent. So make sure that you understand those three terms, so in case you get asked a question about a triangle, you'll be able to answer it because you'll know the definitions of scalene, isosceles, and equilateral. Again, take a moment, pause the video, and I'm going to, and then you can copy down the definitions. Okay, so in this example, we are given the following information. We are told that the following triangle has vertices of this. Want to know is this triangle scalene, isosceles, or equilateral? The first thing we're going to do is we're going to plot the coordinates on the board. So my point A is at point 0, 1, which is here. Point B is here at 4, 4, and point C is at 7, 0. Then what we're going to do is we're going to play my favorite game, which is connect the dots. Once we play connect the dots and we've drawn a triangle, now we're going to determine whether the triangle is scalene, isosceles, or equilateral. Now, in order to do that, we need to know about the sides of the triangles and one triangle, and are the sides congruent, or how many of the sides are congruent. So for that calculation, do we need the distance formula, the midpoint formula, or the slope formula? That's right, we need the distance formula. So even though you're going to be given it on a reference sheet, let's just put it on the board so you'll have it so that we can look at this problem more closely. You can see what I'm going to do is I take the coordinates of two of the points and I combine them, square them, and then add the two numbers together. So let's label our graph. Here's point A, here's point B, and here's point C. So we're going to start with AB. And we're going to plug in the values, the these are my x points, 0 and 4. These are my y points, 1 and 4. So I have square root of x2 minus x1. So I'm going to do 4 minus 0. And that's going to be squared. Plus 4 minus 1. And that's going to be squared. So that equals, well, 4 minus 4. Oh, I'm sorry, 4 minus 0 is 4. 4 squared is 16. 4 minus 1 is 3. 3 squared is 9. So we get the square root of 25, which we know is 5. So we know that the length of AB is 5. Now we're going to do the same thing with BC. Here's my square root symbol. So again, 7 minus 4 is my x's. So that's going to be 7 minus 4, quantity squared, plus 0 minus 4, 0 minus 4, that quantity squared. And that gives me 7 minus 4 is 3, 3 squared is 9, 0 minus 4 is negative 4, negative 4 squared is 16. That gives me the square root of 25, which again equals 5. So I know that BC is equal to 5. And this tells me that my triangle is not scalene, because I see that 2 of the sides are equal. Now, the only question is it isosceles or is it scalene? So I'm going to do the same thing with the third side. So I did AB and I did BC. So now I'm going to do AC. So I'm going to do a little shortcut because I've already done this twice. So my AC is 7 minus 0, which is 7. So 7 squared is 49. And then 0 minus 1 is negative 1. Negative 1 squared is 1. So I get the square root of 50. Now, do I care what the square root of 50 is? No. All I need to know is that it's not the same as the square root of 25. In other words, I know that the length of this side of the triangle is the square root of 50, which means that it's not equal to the other two sides, which means that this triangle is isosceles. And that's my answer. Okay, let's do another one. So I'm going to clear the board. Okay, I cleared the board, and the next question is the following a rhombus? And in this case, they actually give us a picture. So I'm going to go ahead and draw that picture. So I'm going to pause the video while I draw the picture. When I come back, the picture will be complete. Okay, I've now drawn the figure in question, and I want to know, is this a rhombus? Now, how do we know whether something is a rhombus? Well, you will recall in your mini book, you should have all the special properties of the different shapes. And now, we do know that all four sides are congruent in a rhombus, but in what other shape are all four sides congruent? So think about that. That's right, it's a square. So just because if we can determine that all four sides are congruent, that doesn't necessarily mean that we have a rhombus. We could have a square. So what we want to do is we want to look for another way to tell whether something is a rhombus. And we do have the special property of rhombi. Rhombi is the plural of rhombus, and will tell us that it's a rhombus. And that's that the diagonals are perpendicular. So if I can prove that the diagonals are perpendicular, I can then say that figure ABCD is a rhombus. Well, how do I prove that the diagonals are perpendicular? Well, if you recall, we talked about perpendicularity yesterday. We, of course, also talked about it in the past. The way to show that two lines are perpendicular is if the product of their slopes is -1. answer is -1, we know that they are perpendicular. If the answer is not -1, then we know we don't have perpendicular lines. So let's here, since we want to look to see what the slopes are, which of the three formulas do you think we're going to use? The distance formula, the midpoint formula, or the slope formula? I wonder. That's right, it's the slope formula. So let's just put the slope formula up on the board so that we can work with it easily. Remember, it's the change in y. Slope is defined as the change in y over the change in x. So I have two line segments. I have BD and I have AC. I'm going to figure out the slope of each of those lines. If the product equals -1, I got me perpendicular lines, and then I got me around. So let's first take a look at BD. Let's take a look at the coordinates. We have 0, 4, and we have 2, 1. So my slope formula says the change in y. So my y is 2 and 0. So it's 2 minus 0 over 1 minus 4. Well, 2 minus 0 is 2. 1 minus 4 is -3. Let's take a look at AC. I'm going to start with C because these numbers are bigger and it'll hopefully give me a positive number. So I'm going to do 5 take away 0, and then 4 take away -2. Be careful. That gives us 5 over 6. So let's multiply those together. Let's do that over here. 2 over -3 times 5 over 6. We multiply across. I get 10 over -18. 10 over -18, of course, is not -1. So therefore, ABCD is not a rhombus. If you have any questions,